Greetings everyone, my name is Mark and I'm a high school student. I'm aspiring to become a quant and I enjoy math and finance. I'm mostly recording these videos for myself because when you try to explain something, you remember about 90% of the things that you say, whereas if you only go through your notes, you only remember about 5% of the things that you read or write down. Therefore, I'm explaining these and recording these videos in case I get stuck, I can get back to them, and since that I'm already recording them, I might as well upload them and someone might find them useful. I plan on covering multiple topics from simple mathematics to complicated quantitative methods, and today I'll be looking at absolute value equations, and specifically absolute value equations that are a little bit more advanced. So for those of you who don't know, absolute value equations are equations that have a certain term in the absolute value brackets or in the absolute value parentheses, or just simply in the absolute value bars. Everyone calls them differently. So if we were to have a normal absolute value equation, for example, x plus 3 is equal to 4, well then this would be either equal to 4 or it would be equal to, in the absolute value, x plus 3 is equal to negative 4. And then we just calculate it regularly, or just we solve the equation as we would usually. So that is x plus 3 is equal to 4. That's minus 3. X is equal to 1. And in this case, that would be x is equal to negative 7, because negative 4 minus negative 3 would be negative 7. So that's rather simple to do. So today we'll be looking at the more advanced equations. And the first type, which you will probably see most likely in school, is the case where you have two absolute values, where you have x plus 3 is equal to 2x plus 6 minus 8. And in order to solve this, what you first need to do is you need to think about the equation a little bit differently. So let's take a look at our at the certain terms that we have, specifically x plus 3 and 2x plus 6. So what you can do here is that you take x plus 3, or 2x plus 6, doesn't really matter, and then you solve that what's equal to 0. So you can just rewrite the equation. X plus 3 is equal to 0. You get x would equal to negative 3. And this negative 3 that you get right here will be one of our intervals, which we will then plot on a number line. So this would be, that is a terrible number line. That is equally as bad. Let me try one last time. That's all right. So if we were to have a number line, we would plot negative 3 right here, and on our number line will be intervals will be created. So it's either going to be two or three intervals. We're going to find that out by solving again. 2x plus 6 is equal to 0. So that would be 2x equals negative 6, and x would equal negative 3. So in this case, we will have only two intervals, since that x in both cases equaled to, sorry, not 3, guys, negative 3. There we go, negative 3 again. So in this case, we had only we will have only two intervals, and the intervals will be from negative infinity to negative 3. Negative 3 is not included, because if it were, then it would equal to 0. And then the other interval is from negative 3 all the way to infinity. So these are now our two intervals, which we will be now confronting. And now what we're going to do is that we're going to try to find for what term does this interval work for. So essentially what you can do is that you can plot a table, just like so. where we would have x plus 3 right here. And here we will have our second term, 2x plus 6. Here's our first interval, negative infinity all the way to negative 3. And then from negative 3 to negative infinity. Sorry, not a negative infinity, positive infinity, just like so. And now what we're going to do is we're going to try to figure out whether if we take a random number from this interval, for example, negative infinity to negative 3, and if we put that in x plus 3, if we are going to get a positive or a negative result. So, for example, let's take negative 4, which belongs to the interval of negative infinity to negative 3, and let's replace that for x. So negative 4 plus 3 will be equal to negative 1. Therefore, this absolute value right here will always be negative when we plug in for x any number which belongs to this interval. So you can go and rewrite that as negative x plus 3 in parentheses. And we're going to do the same thing for 2x plus 6. So let's take negative 4, for example. You usually try, putting in numbers for x that are whole, so that, it'll be easy to calculate. So that's negative 8 plus 6 is negative 2, so that'll be also negative. And you can go ahead and rewrite that as negative 2x plus 6, just like so. And now we're going to do the same thing for x plus 3 and 2x plus 6, except this time it won't be the interval of negative infinity to negative 3. It'll be from negative 3 to infinity. And of course, negative 3 is not included, therefore we can't put negative 3, because if we would, well, then we would get 0, and that's not negative nor positive. So instead of negative 3, for example, let's put a negative 2, so that'd be 1. So you can go ahead and rewrite your absolute value as it is in parentheses, and this would be positive 2. So that's 2x plus 6. It's positive. And now let's solve for x. So what we're going to do now is that we're going to take these new, not absolute values, but these expressions or terms or whatever you want to call it in these parentheses, and we're going to substitute them to the corresponding absolute value. So negative x plus 3 will go instead of the absolute value of x plus 3, and negative 2x plus 6 will go, will take the place of 2x plus 6 in the absolute value, for example. So that would be negative x plus 3 is equal to negative 2x plus 6 is equal, sorry, not equal to, minus 8. I'm usually used to that. I just have one term on the right side, so therefore. Cool. So now we can just go and solve the equation as we normally would. So you distribute the negative sign because it's not just a negative sign. It's actually minus 1. You just don't write the 1 there. So that's negative 1 times x, which would be negative x, and negative 1 times 3, which would be negative 3, is equal to negative 2x minus 6 minus 8. So we can add 2x to the left side and to the right side, so that would be x is equal to, and then we could add 3 to both sides, so that would be negative 6, negative 14, negative 11, so x would be equal to negative 11, and then our next case would be x plus 3 is equal to 2x plus 6 minus 8. So again, same story, except it would be negative x is equal to 6. That's -2 minus 3 would be -5. So essentially what we did here is that we subtracted 2x from both sides. On the left side we got -x. On this side we got 0, so this canceled itself out. 6 minus 8 would be equal to -2. And then we would just add 3 to both, subtract from 3 from both sides. This would cancel itself too, and we would get -5. So x would equal to 5. We just multiplied this by -1. So that's 5. So x in this case would be equal to -11 or 5. And if, again, you would plug these numbers into the x, which is nested in the absolute value, the equation would be true for -11 and -5. So the other type of absolute value problem which you might see or you might encounter, apart from the problem where we had 2 absolute values or maybe 3 absolute values, you get a problem or an equation where you have an absolute value within an absolute value, which is nested in an absolute value, obviously. So what you want to do here is that you want to have the same principle as if you were to solve a normal, for example, 3x plus 4 is equal to, I don't know, 2, doesn't matter now. So essentially what you would be doing here is that you would have essentially 2 equations would be equal to 2, and the same would be equal to -2, because again you're trying to find the distance from 0 which x has on a number line. That would be the geometric explanation. The arithmetic would be that if you have whole numbers and you're trying to figure it out, well then for a is a number which would be the opposite to a, so that would be -a, but that's for another time. So in other words, you go on solving this the same way as you would a normal absolute value equation. So just simply remove your absolute value brackets or absolute value bars, if you will. Just go ahead and remove them. So that leaves us with x minus 9 is equal to 7. And as I've already mentioned before, you just go on and solve it like any other normal absolute value equation. So your other options, so we can write or, so it would be equal to x minus 19 is equal to 7, or x minus 19 would be equal to -7. Just like so. And then you go and just solve these as you normally would. So this over here would be the absolute value of x would be equal to plus 19 right here, plus 19, or actually no, that's, I can't even see that. And then you go plus 19 to both sides, plus 19, plus 19. That would be equal to 26. But as we know, the absolute value needs to be equal to the positive and to the negative. So x would be equal to 26 and -26. And over here, we would have the absolute value of x would be equal to, again, rather simple, plus 19 on the left side of the equation, and the same for the right side. So that would be plus 19 plus 19, and that would be equal to -12. No, that would be equal to just 12. Sorry. So that would be equal to 12. And as we know, it needs to be the positive and the negative. Now, if you would go ahead and plug any of these numbers that we've got right here into for x in the absolute value, then the equation would be true. So these are our two essentially more advanced, so to speak, absolute value equations that you might come across. That's all I have prepared for today. Thanks for watching, and stay safe.